Hello everyone. Welcome to the webinar. We just started it on time. A lot of familiar names in our audience. So I'm Mathieu, the head of product at ShapeDiver, and I'm joined by Edwin. Hi, Edwin.
Hello everyone. So I'm Edwin, the project manager and main parametric designer on ShapeDiver.
Yeah, I think you might have seen us if you joined some of our previous webinars, or of course if you watched some of the videos that Edwin uploaded to our YouTube channel. And yeah, the reason we are gonna present together today is that we'll talk about the viewer API of ShapeDiver, but we're gonna try to keep it not so technical and kind of focus on the high level overview of like the things that maybe you're not aware that you can do with the viewer API, and also keep a tie with like the Grasshopper world and essentially when you use the ShapeDiver with the viewer API. It's always like a collective work, so it's always like a collaboration between someone in Grasshopper and a web developer, and how how the data travels between Grasshopper and the web application is something that you have to pay attention to, and make sure that everything is prepared correctly in Grasshopper. So essentially, the way we're gonna look at things today is that we're gonna progressively look at like a lot of features in the API, and every time it makes sense and it's relevant, I'm gonna hand over the screen to Edwin, and he's gonna talk a little bit about how to organize things in Grasshopper, how to make sure the developers on the API side get the data they expect and can use what is sent by the model. Maybe another quick word before we start. As you can tell already, we're already pretty deep in I'm not going to explain what Grasshopper is so much, which is also why we asked the question. And if we look at the result of the poll, I think we have a vast majority of people that have at least some experience with Grasshopper, and a lot of experts actually. So that's really good. And we're not also going to spend a lot of time re-explaining exactly what ShapeDiver is, but it's going to be built in the webinar that, of course, it's gonna be a topic. But yeah, we're going to keep it short and go kind of straight to like the more API related questions. And in that regards, we have approximately a third of people that have already played with the API, so that's good to know. But like the majority of people is not very familiar, which is also the reason why we're gonna keep it relatively high level, and keep maybe more technical questions for the Q&A session at the end. And also, of course, right after the webinar, even like now we already have some, but after the webinar we're gonna keep releasing all the code examples we discuss here, and even like some videos we'll add to our YouTube channel aimed at developers to help them get started with a lot of the features. Anything you want to add to the introduction, Edwin?
No, everything is clear, so we can get started.
Let's get going. Yeah. So I just, it's kind of like a spoiler for what we're gonna try to do. But like the goal of the webinar is we're gonna look at a lot of features and slowly build a scene, like a pretty big scene that contains kind of like everything we're gonna talk about. So this is the final goal of today's webinar. We have this scene that's a complex scene built from, you'll see like several parametric models, and using a lot of the features of the viewer API. So using interactions with the model, some animations, for example, on the shelf, using anchor points, so like all the data, making the best of the data that's sent from the Grasshopper side, and really showing the extent of the possibilities we have in the API. Yeah, I wanted to. Yeah, that's the only one I wanted to show. So like repositioning some objects in the scene. And yeah, I'm not gonna say everything yet because we're gonna keep some surprises along the way. So yeah, and in order to get started, we wanted to start with like maybe a reminder for most people of like the core, I mean, the first reason and the most simple reason why a lot of our users use the API, which is that right after you upload a model on ShapeDiver, of course, you can then you get this interface on a ShapeDiver platform that contains, a visualization of all the geometry outputs from the definition and the parameters exposed directly from the Grasshopper definition. And you get our standard platform UI, of course. And the first thing that a lot of our users want for various type of online applications, from e-commerce to presentations and collaboration applications, etc., what they want is to get from here to to their own website, own application with their own UI, styling, etc. Right? So it's going from this ShapeDiver model uploaded on the platform to this type of custom UIs. That already includes also some kind of movements here, where you can really interact with the model in a very intuitive way. And to show this like first application of the API, that's when I'm gonna first give the screen to Edwin, who's gonna show a bit how everything starts in Grasshopper and how you can structure the data in Grasshopper, the parameters, etc., so that you already have a lot of usable data when you upload the model on ShapeDiver and also in the API as well.
Yeah. So just as a reminder, some of you may see that the video of Matthew is a bit laggy, but that's just because of the streaming. Actually, all the movements are pretty smooth, but the streaming, of course, doesn't show all the smooth movements that that Matthew may be seeing in his computer.
Thanks for reminding me, because it's really smooth here, but yeah, the streaming is not great. But we'll share some links by the end of the webinar, and you'll be able to see it for yourselves.
Correct. Okay, so we will start with a very small view of this Grasshopper model, just to see how to get from Grasshopper to ShapeDiver. We have touched this in several webinars, but just as a quick reminder, we have here some parameters at the beginning. These parameters can be native parameters of Grasshopper, so sliders. Here we have a value list. It can be a toggle. It can be a color swatch. It can be lots of the parameters that already Grasshopper offers. Plus, of course, in the ShapeDiver plugin, you have also here the input section where you have more parameters that are more custom parameters. So all of that we have here with already names. So all of this has some names that are important, because those names are the ones that will be shown in the ShapeDiver platform, and also they will be important when you want to access those parameters via the API. These parameters are the ones that these names are the ones that you will look for through the API. So here we have, in this case, two groups, dimensions and other options, I just called it. And those groups are also important, because that will also reflect differently when you upload this into ShapeDiver. And on the other side, we have just a single output, which is a display ShapeDiver display output, which you find here in display, GLTF 2.0 display output, which we will check later in the webinar. And then when we go to ShapeDiver, so shapediver.com/app, then you can log in if you are not logged in, or register, and then here you will find a big upload button. I can just drop there the model that we want to show. So in this case, this one is the one that I'm working on. So I can just drag and drop it, and our servers will process it. Then we will be able to check already this Grasshopper model online. So now it says that it's ready. So we just click on Open Model. And now we will be able to see how Grasshopper gets reflected into ShapeDiver. So now we see here we have two groups, as we have in Grasshopper. So dimensions group with all what we defined there, and also other options group. And of course, we have here our 3D model and some settings that we can change here regarding the scene itself. Now we will focus in the API, of course, in this time. So the first thing that we want to do is see these parameters, the inputs,
in our API. And the easiest way to do that is through the console. So if you right click in here in any part of the screen and then you click on inspect, then you will be able to access the dev tools, and then you can go to console, and then through the console you will be able to access already the API.
Yeah, and
So
let's have a quick note that actually, you know, the API tools, they are not available with for free accounts, but actually even free users can test, you know, before everyone can test in the console like this what the API looks like, how to use it to do any of the features we're going to talk about today.
Correct. So this is something that everyone can do, access through the console, the API, but of course this is just for testing because it's not that useful to just have the use of the API through the console, but it's a good way for you to test if you need to debug or if you need to just do a quick learning exercise with our API. So again, right click, inspect, you get to the DevTools, you get to console, and then here with SDB, you can access the API. And then here, for example, I want to access the sessions, which we will dig into that a bit later, but basically one session is one Grasshopper model. So in this case, we have this Grasshopper model, which is called the model edit session because we are right now in the edit mode of the configurator. And then, for example, here I have all of the parameters. So if I check the parameters, then I check that I have 1, 2, 3, 4, 5 parameters. And then if we check here, we have 3 here and 2 here. So it reflects exactly the same. And then if we check one of them, we have, for example, here the name of this one is depth in centimeters, which is this one. And then if I check the group, it tells me that the name of the group is dimensions, which is here. So as you can see, you can access all of the information that you see intuitively, that you see directly in the ShapeDiver platform. You, of course, can also access it, edit it, and view all the information through the API. Now, Mathieu will take over and dig more into this.
Yeah, one other one is like the order also is reflected, and also the visibility. So you have this hidden property. And so here in the edit mode of the model, you know that you can hide or show parameters directly on the platform. And the idea is that it's also stored in the API, the state, the visibility states, the order of all parameters, which group they belong to, which means that you can really, so I'll try to share my screen. Can I take over? Which means that you can really build a dynamic UI and actually build it in a way that, you know, you can still control your own on an application through the edit mode of the model on ShapeDiver. So here, that's where we have the first, and again, I'm not, we're gonna keep it high level, but that's the first code example that we already have in our documentation so that everyone can see. I don't know how to, am I sharing my screen? I know not yet.
I cannot. No.
All right. So we have like most of the code, the examples we have today are available on Code Sandbox. It's a nice platform that allows to really make structured code examples. And here we have this first example, and you can see the code is very compact, right? And that's an example that essentially is compatible with any model on the ShapeDiver platform. So, for example, if I now open one of the models in my library, and if I go to the, so simple, just like 4 parameters, and if I go to the edit modes, that's where you have the embedding option, so you can allow or not embedding. I think a lot of you are aware of this. And if you allow embedding, you have the 2 pieces of data you need to you know, use the API with any model on ShapeDiver is a ticket related to the specific model, and the model view URL, so which URL to communicate with when embedding the model. So in my case, the URL here I think is already correct, and I can replace the ticket that's in this model and reload the code. And here, what we have is that I have the code that's under here just like looks at the parameters that are in the session. So what Edwin just showed. It sorts them through the order property that we have, which is why here the order of the parameters that I create respects the same order that we had in the model. and then creates a simple HTML element. So in this case, I really did not style anything. It's like really the basic styling that I get in my browser. So there's no CSS at all, right? It's really to just show the connection here. I could create all the parameters, and then for each of them, connect them with the updates. So you can see also that I look at the hidden property for each parameter to not show them if they're hidden. If I decided to hide them in the ShapeDiver platform, and then connect them. So I have to find where the customize call, yeah, session.customize. So for each parameter, I can update directly the value and then customize the thing. I can show that real quick. For example, here I have this parameter called diamond shape with 3 options. I can show the quick call that is used to update it. So if I go to the API, to the session, so the only session I have here, which is my, like for Edwin, is my model edit session. So when you create a session using the API, you can give it any name. We just have these default names for sessions on the ShapeDiver platform. And then we have parameters. I can even look for a specific parameter by name. So let's say if I want to update this diamond shape, I'm gonna enter diamond shape, and then I can update its. And I think here, since it's wait, what do we have? I have to check again. Oh yeah, so it returns an array. So here I have just one element in my array, and then its value. And the value here for like drop down parameters is just the index in the array of values. So you have a round and roll. So for example, now the value is 0. I can update it to 1. Okay, it should be a string. And then I can call this directly on a session. So I can do that for several parameters at the same time if I want. And if I call the customize function, I can directly customize that with this API call here. So it's really, I think this example is the one we send to all the users because it's really a very good template to connect any UI. Even if you already have an existing UI in your online application, you can just add the ShapeDiver model and connect it using this template. It's extremely easy. So that's how, of course, you can, here in this case, it's really simple UI elements. But of course, if you have your own UI, custom UI, you can do even more interesting things. So for example, this user ShapeLamp, they created this quick canvas where you can create the profile of their lamps. And here, actually, the parameter, I didn't check again, but I believe it's probably just an array of points or a JSON object maybe that is sent using the direct text input parameter type from the ShapeDiver plugin. Is sent to Grasshopper like this, parsed in Grasshopper, and used to build the entire lamp, right? So you can really have fun with building this type of UIs. Edwin will show even a more advanced one in a moment to draw floor plans and use them in a Grasshopper model. I had a last example of such custom interfaces from our other users from Actual. And here again, really completely having a custom UI that's even quite complex and connected in a very custom way to like the set of parameters that's stored in the ShapeDiver model. Okay, so that's really the first the level 1, let's say, of using the API. It's really just like the level of connection with like communicating with the models in the backend, get back the geometry and the data that comes out of these models in the back. But of course, we have a 3D view, and we get back from the backend. So the ShapeDiver models, when they send back the data, they send geometry, they send data using the data output component that we have. And even you can even export files, as most of you know. So you even have access to like file exports directly there. So there's really a lot of information, and this information is actually sent to the front end in a very structured way, which makes it really convenient to create interfaces that go a bit beyond just like a separate interface in HTML and a 3D canvas, but actually use the canvas as part of the interface. And that's what we wanted to show in the second step here. So that's the same couch actually, different default parameters here, but that's the same couch model that Edwin was showing. And the first thing we do here is that we use in the first very simple way, the interactions module of the viewer API to basically make objects clickable and to react to, using an event system, react to what happens when you click on these models. In this case, very simple. I click on this model, two things happen. The first thing is that I zoom around this model. I can zoom back out. And the second thing is that then when clicking, we make a custom UI appear that is actually an element in the 3D interface. So it's positioned around according to some data that comes from Grasshopper and showing the visible parameters of this model that we defined as visible. So this part of the code just uses what I just showed you in the first step. But now we're going to look with Edwin at how to send data so that we can build this anchor for this menu.
Okay, so we are back in the SOFA model, the same one that we were checking before. Now we go back to the outputs. We have the display section, but we also have this blue section that is how we represent all the exports or outputs that we have.
Are you showing your screen yet? I don't see it. Ah, yeah, now it's here.
Yes. Okay. So we are here in the output section. We have the display, and then we have the blue section, which is for outputs. And in this section, what we do is we basically take all the geometry that we are creating. We create the bounding box of this geometry, and then we want to have 2 points of the geometry. We want to have a menu point and an anchor point. So the menu point, we just position it here in the top, in the back of the sofa. That is the same point that is used through the API to be able to position this menu. So the menu will be always positioned in this point. So I could change the point to whatever I want. And through the API, you can always make your menu in this case, or you can make anything else to follow this point in the viewer. In this case, we are using in the output section. So if you go to the ShapeDiver plugin, the output section, you have the direct data output component. And with this one, you can output all sorts of data. So right now we're outputting a point. So basically in the API, we will get X, Y, Z coordinate. So 3 numbers, but you can input all sorts of data. You can input JSONs. You can output JSONs. You can output text. You can output all sorts of data. In this case, we just have this point. And this anchor point is also just 3 numbers, which we will use later in the webinar to be able to position this object into an scene. Okay.
All right. I'll share again. This jumping around screens is sometimes a bit difficult. Okay. Do you see my screen again?
Yes.
Okay, so I mean, as Edwin mentioned, so here I can, if I update parameters of the couch, so for example, if I make it not as wide as it is now, of course, the anchor point that is sent by the backend will also update, and the API is connected to this point and updates also as well, right? So, and here I can go back, and I think I had. Let me check. Yes, I have the sofa here. That's another thing that's, again, is simple enough. It's as technical as I'm gonna get today. But just to show how it looks on the other side, essentially. So here I am in the view session, normal view page, and we can look at what it looks like when we get the data sent by Edwin in the model. So here I can get the output by name, and I think it can you. So here I don't know how you call it. Menu point like this. Yeah, I see something. That should be it. And here, if you get this output by name, you'll see. So it always sends you an array because names are not unique. So you might have different data outputs that have the same name. It's good practice to have unique names. That makes your life easier. You can also identify it by ID. So every output, every parameter, every entity that's sent to the viewer API has its own ID. But in terms of developer experience, identify things by name is a bit simpler, in my opinion.
So as you saw in the inputs, just to clarify, as you saw in the inputs, you need to send names because the names are important because then you can with that recognize the inputs, and the same happens with the outputs. Now in the outputs, the name of the component is important because then that's what you need to be able to recognize and access information in the API.
Exactly. And here in this case, so we can look at the content that's in this data output, and we can see, so the format is data, the name of the content, and the data that's actually sent. And in this case, so Edwin did not go into too much detail. We support a lot of different types of data, so the native Grasshopper data types. In this case, a point is converted to an array of three numbers. But we actually support, it goes pretty far. I don't remember everything, but I'm pretty sure if we send, for example, a polyline, that converts that to like an array of points, so an array of arrays. But I think even like a NURB surface comes with like the degree and the control points and everything, so you can send really a lot of data using this component.
Correct. All of that gets converted automatically into a JSON.
Yeah.
And then JSON contains all of the information.
Yeah. And of course, here, once the data is here, you can always use it to do anything you want in the API. In particular, you can just listen for the whenever parameters get updated, and when that happens, check data again and hook up whatever UI elements or behavior you have in the front end with those outputs. Just to show it also, like another thing. So like another thing we did in this model was to hook up the click on the model with a camera movement. And here, this is something that is in the viewer API. So we were in the sessions API now, and this is like the viewers API or viewers interface, if you want. And here is where you can really play with a lot of the settings of the viewer. So like basically all of the ones that you already know from the edit mode. So from playing with the edit mode, they can be updated directly through the API as well. But also do some things like accessing the camera, accessing its current position, and update it. For example, I can zoom back to the scene like this and directly zoom on the camera. So again, like just to show that it's pretty exhaustive, and like you can do everything you can do directly on the ShapeDiver platform is available in the API, but of course also a lot more. The last thing, of course, of this part was like how the interactions parts, and this is a bit more intricate, of course, but I just wanted to show that this is already all documented in our help center. So you have all these code examples, and basically you can see again, if I open this sandbox, for example, separately, it's a very little amount of code just to look at a scene, create what we call the interaction engine, which is where from this interaction engine you can target one or several objects, or all. So here in this case, we send all these meshes separately, and we made them clickable independently, separately. And we also defined what happens when you click on them. In this case, it's just an effect that turns them red. So all of these codes examples are already in our documentation. Okay, so that was the level, let's say level 2, at least part 2 of the webinar. And the next thing then that we wanted to show is how you can go a bit further, even using again these interaction modes, and in particular how to add animations to the different geometry assets that you sent from Grasshopper. So in this case, we have this shelf, and we just added two types of simple animations: rotations for the doors, and translations for those drawers. Of course, with the API, you can bind them dynamically. So even if like the geometry changes, for example, if I add a drawer from the back, so any parametric change, all the animations will adapt. So in this case, I have the translation for the added drawer. And actually, what I wanted to do is change the wardrobe width. Okay, if I make it thinner, it's gonna start looking weird, but it's just for the sake of the example. So now it's thinner, and that's what Edwin will show in an instant in Grasshopper. Is that, of course, the rotation needs some information from the geometry that comes, right? Because in this case, compared to like the other set of parameters here, the pivot points for the rotation, the axis, etc., have been updated, right? So here Edwin will go a bit in detail on how we can send this data included with the geometry that comes from Grasshopper, and that's going to be a quick introduction to our attribute system.
Correct. So let me know when you see the screen.
Yep, it's here.
Okay, perfect. So this is the second Grasshopper model. This one, of course, is way more complex than the previous one. As always, in the black section, we have all the inputs. And as you saw, when Matthew was clicking on the object, there was again this menu popping up where we had these parameters. So exactly the same parameters with the names that were defined in Grasshopper, with the same order and the same options. Some of them were hidden. For example, this one was hidden in the ShapeDiver platform, so it's also hidden. Then
no, this one we had. I used
this
it.
one was.
I think another one, the drawer height, maybe. Yeah.
Yeah, I mean, here we have also, in this one, we have actually lots of parameters. For example, all of these materials, all of this is there as well regarding exports, but we are just using a few of them, again, because some of them are hidden by default through the ShapeDiver platform. And then here we have, well, here we are creating just the model, the handles, the shell, the shelves, and internal drawers. But the main important part is how to create the animation. So the animation, of course, is triggered through the API, but we need to send the information of how the animation should look like through Grasshopper. So in this case, for example, for the door animation, we are taking the mesh of the door, we are taking the bounding box of them, and we are sampling 2 points of this bounding box, which is basically the pivot point where this object will rotate. So here we have pivot. Then we have also the axis. So it's through which axis should it rotate. So in this case, it should rotate through the Z axis and through this pivot point. And then how much it should rotate. So that's the angle. And then here is where we have minus 90 and 90, because one is for the right door and the other one is for the left door. So we have opposite angles. So in that way, we give all of this information directly to the API. So of course, if we change any parameter here, the width of it, then the points change, and those points also change in the API, so that the animation is always correct. The point will not stay well where it was originally. Now all of this goes into this one that is an end-to-end component that basically just creates a tree. And the reason why we have that is because we want to create a JSON. This JSON contains all of the information that we need to create the animation. So here we are using all this component that is the ShapeDiver construct JSON component, in which in one input we're giving the data as a tree. In the other input, we're giving the address of this data. So in this case, for example, in the first one, we have the axis, which is just a Z vector, which is goes to the branch 0, and then in address 0 we have that this particular this axis goes into the address value that axis. So if we check the JSON, here we are in value, and then we go inside axis, and then inside axis we have an array of 3 numbers, which is representing the Z vector. And the same happens with the rest. So for example, here we have the pivot point. One pivot point comes to 1, 3 because it's for the left door, and the other one goes to the other 3, which is the right door. And here the same, we go to value, that pivot, and we get 3 numbers, which is basically the X, Y, Z positions. And finally the angle, but the angle in this case, we are converting it into radians, and that's what we are sending here. This additionally here is just to tell the API how this animation should happen. So in this case, a linear animation. Which kind of animation should happen? So in this case, we have a rotation, and what is the time when it should happen. So in this case, we're saying that it happens from second 0 to second 2. If we check the other, which is the drawer animation, this one is a bit simpler. And what changes mainly is here the path. You can see that is now a translation. If now this changes, that means that our values also change. So here, when we have that the path is a rotation, then we need to give axis, pivot, and angle. But when the path is a translation, then we just need to give a vector. So that's why now it's way simpler. Now we just have here 3 numbers, which is basically telling that each of these drawers should move minus 400 in the y-axis, so in this direction, basically. Now, all of this data, we need to somehow store it or send it to the API so that we know, okay, this JSON file, which describes how this door should move, needs to be linked to the actual door, to the geometry. And the way we do that is through the attributes. So in the previous webinar, we talked more about that, about the new Grasshopper plugin of ShapeDiver, in which we introduced the new attributes components that now we offer. And this basically allow us to embed information inside inside our geometry. So in this case, for example, we have door left, and then here we have the mesh, which is both of them. And here we are just accessing the left door. So here we have just the left door. And to the left door, we are injecting some information. Which information? Here in this case, we have 2 keys, 2 attributes that we want. One is called animation, and the other one is called material. And here we have that specific information. So one is the animation that we just checked, which is a JSON file. And the other one is the material, which we are creating back here. And that material is just created through our material components, which are also in the ShapeDiver plugin display section. We have all of the materials. And then here we are using the GLTF 2.0 material component to create it, so that we can attach both of these attributes. Then we create the attributes through the construct attribute component, which is here in 2 attributes. We have construct attribute component, and then we need to inject this information in the geometry. So here we have the left mesh, which is the object, and the attribute, which is what we just checked, these 2 attributes, material and the animation itself. The same happens here for the door, the right door, and the same happens here for drawers and handles. So that when we are in the API, we will be able to know how this object should move, because the information is already attached to the mesh itself. It's not somewhere else, but it's attached to the mesh itself, which is different to the other way that we were sending information, which is with the normal data outputs components, which is again in outputs, direct data output, which this one is not really attached to anything. It's not attached to the geometry itself. It's just some global information that you may want. In this case, it's just the menu point and the anchor point. But this one could include, for example, if you want to know the pricing, if you want to know the area of something. So is not attached to some geometry, but it's something that is just global for you to use through the API. Okay.
Exactly. And I think what's really interesting here that is why we spent a bit of time is that in terms of development, we know there's a lot of really good web developers, but sometimes knowing about like 3D development, working with WebGL and stuff is like a very specific set of skills, and it's like it can be really complex also just to manipulate geometry. At least it's much more complex to do it in an API and in JavaScript, for example, than for a Grasshopper person. So creating all this information about how should things move, how things should be animated, is much easier to create in Grasshopper, attach as attributes, and then that's why in the ShapeDiver API, you just have a simple function to call to just use this data that comes from Grasshopper instead of having to like create all this logic from the front end. So maybe I can take the screen again, Edwin, if you're, yeah, exactly. And not to mention, of course, the pretty amazing things that can happen if you by defining basically all this animation data is parametric, right? So like really defining parametric animations, even for potentially like a lot of different pieces of geometry at the same time. Again, that's something that I'm not going to go into too much technical detail, but we already also have some code examples regarding animation, and a lot more are going to come in the near future here. But it starts a bit the same with the interactions module. You can identify pieces of geometry and then apply things to them. What I did want to quickly look at, if I go back to the, I keep missing, which one? The shelf. I wanted the shelf model to show the attributes. I thought I had it here.
Animations like demo.
Somehow, but that's the example here. But I wanted to open the ShapeDiver model to access the attributes. But okay, anyways, that was a bit the most complex part in the API. But just as a high-level overview, so all the geometry here that comes from Grasshopper keeps to some extent the data structure that comes from Grasshopper, and this data structure gets translated into the scene tree, so what we call the scene tree of the geometry in the ShapeDiver viewer. So, and essentially you have all of this geometry here, for example, for this shelf is represents different nodes of the scene tree inside the viewer, and each of these nodes, if you have used the plugin to store attributes, each of these nodes may contain attributes that then you really have directly, you can identify each piece of geometry and which attributes are linked to each piece of geometry, which is why you can just, without, it's kind of a black box from the viewer API here, is that, okay, I have this piece of geometry, I know I have this animation attribute that's stored inside this piece of geometry. So I can just directly connect it using this piece of geometry with the data that was stored as attributes, essentially, and stay really high level from the API's perspective. So yeah, like to finish this, I wanted to show maybe just one example again of how some of our users have been implementing this feature. And here we have one of our long-term users, Unruh Furniture, and they've really made a lot to play with all the features that we're talking about today, the camera movements, etc. And here in this case, even some playful animation. So these tables can have extensions, and when you add them here, it's a bit more work than just sending just a rotation or translation, but really hooking how to install the extensions directly in the table. And when they're removed, I think I believe it's the same. They just disappear like this. So it's really like making the best of like connecting all the different elements that the API brings to the table. Okay, so now we have looked at how to like really make the UI part of the 3D scene, and how to like make each model that you can load from Grasshopper a bit more alive by adding animations, interactions with the models. So for the next part, and I think you remembered the scene that I showed at the beginning, we wanted to show how viewer does not equal, so one viewer instance does not equal one session to one Grasshopper model. Actually, when you start a viewer instance, and this is something that, yeah, I have the code example next to it, and I just have it as a way to show how simple and compact it is to be able to load several models. You can create an instance of a viewer, and then you can start one or several sessions to one or several Grasshopper models, so ShapeDiver models in the back. And here, that's where we're starting to like build up our scene a little bit. I believe there's sessions to four different ShapeDiver models here. So we have this nightstand, we have the beds here that can have, I believe, and you know, I'm building up on the different features we saw in the last parts. So here we have the bed, and the bed is already like, yeah, the drawers on the side are already also connected with some animations. And what else do we have? We have the couch and the shelf that we had from the start. And as you can see, I can also open several sessions to the same model. That's not an issue at all, right? So I have those two couches are connected to exactly the same ShapeDiver model in the back, but two separate sessions are open to them, right? So like when I update them, of course, they are not connected at all. I can independently interact with both of the couches like this. So of course, you can, from like a practical perspective, we can see how complex we can build applications. In this case, it's kind of like a fun way to show an entire room. But in general, this is also something that's really relevant for like complex applications in terms of splitting up the logic, and maybe like having logic separated in separate models that are completely independent from each other, or can even communicate with each other. So it's quite simple to essentially have a model update parameters of this model, and then when the update is finished, look at the output from this model and connect them maybe to another model, for example. So yeah, this is how to like load several sessions and create, you know, this more complex scene in one viewer. What we wanted to show is that, and Edwin is going to show this, is that here in this case, actually the whole room model is its own, so that it's another Grasshopper model that's defined separately. And we wanted to use this opportunity to show this floor plan example essentially, and how you can really use it to connect it with interesting UIs on the one hand, and also how you can use it to, with the data outputs, to connect to how to place objects in a scene, for example.
So yeah, just to be clear, all of those models that you saw there are completely independent. So in Grasshopper, they don't know each other. So this is the same room model. I mean, just for sake of keeping it simple, we hide the walls and the doors and windows in the final example that we are showing. But actually, the Grasshopper model has also all of those details. And as you can see here, we don't have a sofa, we don't have a bed, we don't have anything. All of that gets together then in ShapeDiver. But here, what we have is a very simple JSON that is just a list of numbers, which defines how the shape of this room is. So in this case, each of these numbers represent the X and Y coordinates. So we have here XY, 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 etc. So it's by couples, and each XY, well, is one of the points that we need to be able to create the room. So here, of course, in Rhino, we can directly explore how this changes, but you could also make something similar in the web, where you could actually move these together, and I will show you an example just in a bit. But as you can see here, when I move my points, well, everything, all the window also relocates. The same happens if I move this one here. All of these relocates. And we have here also another input, which is also a JSON, a bit more complex JSON, because it contains way more information, which is for the opening. So in this case, this JSON is an input of the model, which contains the type. So the type is 0, I think 0 if it's window, and 1 if it's door, or the opposite. Then we have rotation, position, if it's mirror, its size, etc. So in that way, if I move one of these points, and we can see how the window also repositions, and all of this is managed through this JSON. So right now, all of this is for testing. So we use red internally in ShapeDiver to show that it's for testing. But you could create a similar environment through the web, where you can also move all of these objects. So in this case, I have an example to show where you can see how this is translated into an actual web application. So this one is a client in the UK. They're Spaceforce. They create furniture for education, so for schools. So here, for example, I can draw my room. You can do whatever I want. And then I can go next. And then I can insert, for example, windows and doors. So if I move this door here, it snaps, and then we can put it here. We can put a window here. Let's put plant somewhere here. And finally, a radiator, let's say somewhere here. Then we go next. And we can add some furniture. So let's add just some table here and some chair here. So in the background, while I'm doing this, in the background, we're sending information to ShapeDiver, so that when I click next, all what we saw in 2D, now we have it in 3D. So we created what you saw there in Grasshopper, where you just have in Grasshopper and Rhino, where you have these points moving. Now we can create also a similar environment, but on the web, and link it with ShapeDiver in the background, so that when the user is ready, the model also in the background is ready to be displayed in 3D. Okay.
Yeah, exactly. I mean, yeah, and that's it. You mentioned it. It's really implemented in a smart way here, because updates are sent to the servers as you interact with the 2D scene before. It's not just all done at the end, which is why it's really, really fast when you're done with the 2D parts to get to the 3D parts. But yeah, that's a way to show that you can also already communicate with a session that's not even visible, or even use, which is a bit beyond the topic of today, even use the geometry backend API to actually communicate with models and get data from models without even opening any viewer, right? And so without even having to do it from a web client, but also just from a backend.
Correct. Mm-hmm.
Okay, so yeah, and that's where we honestly had like even more ambitions for this webinar, and did not quite get to it. But the idea was also in the room floor in the floor plan Grasshopper models, to define data outputs containing anchor points that would be used to like dynamically place the objects in the scene. So maybe we'll have another webinar, or just like for fun finish this example. But then that will allow to also in this application, for example, move I don't know, like move this point, and then the couch aligning, staying aligned with the wall as you update it. Okay, so here we're already at a pretty exhaustive view of like how to interact with several models in a scene, how to really add interactions, animations, all of these things to the models. But now, of course, when we look at this scene, what we're missing a little bit is a bit more life, which is what, and it's actually a really good. Oh wait, no, I was almost skipping the next step, which is to add the last level of interactions that we did not talk about yet, which is the dragging. And here, yeah, okay, here I am. Okay, so in this next step, and we're going to show several things here. So the first thing that we add is like this frame. So this frame model that's its own, again, like another grasshopper model we add to the scene. And we had 3 instances of the same model in the scene here. And here we use the interactions API to drag it around. So here, this is what's also, we already have some code examples in the part 3 of this tutorial. I think we shared the links of these pages in the chat. And here I can really drag those frames, but also when I drag them, I use the API to limit where they can snap. And in our case, it's just points. You can also use lines and planes to like snap objects to. But in this case, we use this like predetermined points, which could also be defined in the floor plan model. That's also something we had in mind. Each of them is its own ShapeDiver model, of course, that you can interact with. And in this case, this is also something that Edwin is gonna show on the Grasshopper side, which is the file imports and exports options we have, and how to really basically replace the way in Grasshopper you work with local files and instead use work in an online environment. And of course here I have the so I uploaded an image. I can apply like some parametric effect to it. For example, this polygonal effect, and then the parametrically modified image, I can then export it directly from the viewer and have the PNG here. So I'll send back the screen to Edwin so that he can show some of these import and export feature in Grasshopper.
Okay, do you see my screen?
Yep.
Okay, so as you can see here, we have, as Mathieu showed, there was like 4 or 3 frames, and now here we have just 1. So Mathieu is just repeating the same Grasshopper model several times, but actually in Grasshopper we just have 1. And here we have in the inputs we have some default pictures. So we have this one here. Let me. Yeah, the reason why it takes a lot of time is because of the processing of the image that we are doing. I will show that in a bit. So first I will check this to non-effect, so that is a bit faster. So we have here some predefined images that you can use just if the user doesn't want to use any custom pictures. But we also have the option to use a custom picture. And in this case, we are using 2 inputs of ShapeDiver. So in this case is the direct text input component, which is this one. And with this one, users can send this custom image as a link. So you have your image store somewhere, and you can send the URL. And then here, if you right-click on this component, you can decide if there is a default value for this and what is the max length of that text. So in this case, 10,000 characters, could be less, depends on what is your use case. Additionally, we have this custom picture parameter here, which is the import bitmap component. It's also here in inputs, import bitmap. And this one allows you to send the file to send the image as a file. So instead of using a URL, the user gets the option to select a local file in their computer. That is basically what Mathieu did. And through this one, we generate a bitmap that then we can edit. So in this case, because we are not using a custom picture, then we are using this import, and then here we get this image. So if we go to the Squid ShapeDiver Edition plugin, here we have all sort of components that we can use to edit this image. So that's let's say not the core of this webinar, but just for you to see that through ShapeDiver and through Squid, you can really create also very complete, very powerful tools for image edition. So in this case, we go from this image, that is the same one that we see here, and then we have some options of how to edit, how to manipulate this image. So for example, if we go dots, then we will sample this image in several parts and represent this image through dots instead of through the original image, which has no effect. So we are editing this image through geometry. So in this case, now we have a representation through dots, and that happens here. So we are using the Squid component to have all of these curves and apply colors to them. So here we have curves, and here we have colors. These colors are sampled from the image itself. So here we have all the list of colors, and those colors are extracted through the ShapeDiver image sampler. So again, back to the ShapeDiver plugin, we have here the image section, and here we have the ShapeDiver image sampler. So we just have a bunch of points in which we are going to sample the colors of this image, and then based on the effect that we want, so in this case we want dots, so that's why we have all of these circles, we will fill these circles with a particular color. Then in that way, we create all the instructions that we need. So in this case, we are using the draw component of Squid. So back to the Squid instructions, and we draw these circles with some filling, in this case the colors. And finally, through the Squid component that is here, Squid, we are able to create the bitmap that we are gonna show. So here is the final result. That is what we see here in Rhino. And we also allow the user to be able to download that that image. So in this case, here we have the ShapeDiver download export component, which is in the ShapeDiver plugin, outputs, download export component, and we are giving the format that in this case is a PNG format, but I think we also have parameter for that, so you can define if it's different kind of image formats, so you could download this in different formats if you want, and in that way you can export your image through your ShapeDiver application. Locally, you can do also that download. So if you right click, you can export locally and you can get that image. And of course, this is not the only export format that we support. So in this case, we are exporting an image, but if we go back to the closet demo, then here we have two more options. That is the 3D model itself. So we have different formats for the 3D model. So here we have in the Rhino 6 export, Rhino 7 export. Here we have FBX export, OBJ, STL, 3ds, and there is more. All of that is here in outputs, and you here all have all of the options of exports that we have. If you want to know more about details, you want to know details about how these exports work, you can check our previous webinar that is in our YouTube channel. And there we explain more the plugin, because our previous webinar was mainly about the plugin, not about the API. But the main concept here is that through the API, you can send also all of this information. So in this case, an image. But through the API, you can also export all of this information. So in this case, the processed image that Mathieu showed, or here we have also a 3D model, which if you right click on this component, you can also export it locally. Here we have a more complex one. That is the last one that I'm gonna show, which is for the PDF. So you cannot just export an image, but you can also through Squid ShapeDiver Edition create PDFs. So in this case, if I export this PDF, export locally, then I can save it here. And then if we check the result, where did I export it? Oops, cancel, export locally, GH files. Oh yeah, here it is. So
Quick reminder, we have 20 minutes.
yeah. So
Yeah,
if we
we're
go
gonna
ShapeDiver
finish.
PDF export, then you can see that we go from this 3D model to a technical drawing of this drawer, which is also parametric. So that's it.
Yeah, so I can, maybe if you give me back the screen, I can to close this this part, and then we just have one last part after that. Just also go back to like opening the model inside ShapeDiver here. So that's the frame model we have, and just show again how this is exposed. So just like we have in the sessions interface of the API, you can access parameters, you can access outputs, and you can also access exports. So if I look at the, well, I can just get export by name, and I think it's called export image. So that's name. Okay, I don't know. That's maybe not what I should have done.
Yeah,
Export.
output by name.
I get output by name. Okay, get export by name. Sorry, I was in the wrong parts of the API. Export image.
Yeah.
And here it is. And then I think that's where I heard you, Michel, so maybe you help me once more. How do I request the export now? This is what
Well,
we're
it
not
should
sure.
be right there. You can save it as a variable, and then it's a bit easier to see the options.
Yeah, yeah, okay, so I will do it again. Okay, this one. No, that was
the export.
Exports by name, export image. Okay. Okay.
Export by name. You put export by name.
Okay, and then test exports dot request.
You still have an array there because name is not a unique property.
All right, yeah. Let's export dot.
And then you should have request.
Okay, here we go. Just what I wanted to show. The request goes. In terms of the API, it's a promise, so it returns when it's fulfilled. And here I got the URL. And so when using the API, I don't have to trigger it instantly, just like we do on the platform. If I click on this button, it's going to process and export it automatically. With the API, I get this URL, and then I can even download it in the back or store it somewhere else. So I can process it further, basically. Okay, we're just gonna briefly. So we wanted to keep a few minutes at the end for questions, of course. I mean, we can stay a bit longer than at the end if there's more questions, but let's try to keep 10 minutes at least in the official time for questions. So we just have the last part of the webinar, which is what I started mentioning earlier, which is that now we have our scene with a lot of different things, and basically most of the features in the API. We're decided to also give a bit more life to this scene. And for that's why it took a bit longer, because we actually load a lot of things in there. So the first thing we added, and which allows me to take a second to say that all the ShapeDiver viewer is entirely compatible with GLTF2. So with all the standard features of GLTF2, but also some extensions, the most commonly used extensions. And so you can load any GLTF2 compatible assets directly in the viewer. As a matter of fact, all the assets that come from from the servers, from Grasshopper, we package them as GLTF, and they arrive in the viewer as GLTF assets as well. So in this case, we had, for example, there's Sketchfab is a good source of GLTFs because there's a lot of free models that you can explore. And then, so that's the carpet, and that's the robot with an animation included. And you can always download all files. I mean, the free ones as GLTF files. So they're just loaded using the import, the functionality in the viewer to import GLTFs. And we also support the GLTFs animation. So here, if I zoom on the robot, we can see, again, I think you see my screen a bit, the stream is not really good, but the animation is very smooth on my screen. So that's like one thing. And Edwin will show in a moment as like the last detour by Grasshopper, how we build GLTF assets using our display components. But also on the other hand, of course, then you can every time directly from the API download every single, also all these models that I placed in the scene here, download the GLTF that's associated with them. And those GLTFs can be loaded again, since they are completely compatible with any GLTF2 viewer. I can load this model in another viewer as well. And so that can be done directly by getting just a GLTF that we also load in the ShapeDiver viewer. But the viewer also has its own functionality to basically look at everything that's in a scene. So for example, here I have a lot of different models, external geometry, different Grasshopper models, but the viewer can still basically go through all of this and make another its own GLTF asset, single GLTF asset. Here it takes a while because I was mentioning, but I think especially those carpets we got from Sketchfab, they're very big. But now it just exported the entire GLTF, and I should not have closed this viewer. I'll open it again. But now if I try to load it in another viewer, the entire scene that I just showed here is loaded. With some discrepancies, there are things that we look at. For example, the texture here for the bed it's a small bug, but otherwise it's pretty much what we've seen with different lighting settings, of course. So that's just to show like the GLTF input and outputs. But yeah, as the last of course, one of the main reasons, before we go back one last time to Grasshopper, one of the main reasons the viewer has this capability of like putting everything into a single GLTF is that this is used and also can be automatically converted to USDZ, and then makes every ShapeDiver model compatible with augmented reality using this feature. And that's where I think I had, if you follow us closely, you might have seen it already earlier today, but that's where we showed this example of one of our users using this. So exactly using the API to add this AR button in their websites, and basically, play with parameters and make a really unique version of this table, and on the fly create the GLTF and if necessary USDZ for iOS devices, and make it viewable in AR directly like this. So this is something that we think is really kind of a unique feature, because you really have the combination of parametric capabilities and viewing in AR. Truly unique products. Edwin, we go one last time to Grasshopper to look at the display components, and then I think we'll be ready for the Q&A session.
Sure. So do you see my screen?
Yes.
Okay. So as Matthew mentioned, all of the models that we have are converted or are exported, sent to ShapeDiver as GLTFs. And that's done basically through our GLTF 2.0 display component. And with this one, we are able to embed information in our model. So in this case, we are embedding the material information in our model. All of this embedding happens with the attributes that we already checked, where we were embedding the animation. Now we're embedding the materials. So in this case, we have the legs, and we have a particular material that we want to embed in those legs. And we have also the sofa, and we have also particular material that we want to embed. So at the end, we have two meshes, one with each of them with different materials, which get converted into a GLTF. If I right-click in this component, I can also save this GLTF directly here in my local computer. So I don't need to go there. I don't need to go to the API to do it there, but I can also directly here test how my model will look when it is converted into a GLTF. So if I save it, I can put here test, and we can go, as Matthew showed, to any viewer. So Matthew was extracting models from Sketchfab and displaying it now in the ShapeDiver viewer, but we can even do the opposite. So now we can go from ShapeDiver and display in Sketchfab. So this model was the one that we presented in the last webinar. And now here I can upload a model, and I can upload the model that we have here. So test, upload files, and it will be processed by Sketchfab. And this one just had a problem, which hadn't happened before, and now it happened. Let me try one more time. Okay. It was working before.
We had to have one problem with the live demonstration, so that's
Yeah.
the one for today.
But here we have
saw
another.
that maybe textures, maybe something with textures or something like this. Anyways, I think the point was clear. So yeah, those GLTF files that we create using the GLTF component in Grasshopper, they're compatible with, like, basically, as long as you have a viewer that says they're compatible with GLTF2, then those files can be loaded there.
Try one more time, and that's it. Because I had already tested this. Not sure if something different. Okay, there we go. This one worked. So
Good.
I had tested before and it was working, so that's why I knew it was working. So here is now processing by Sketchfab, and then we will be able to see the model that we saw in Grasshopper. We will be able to see it in Sketchfab. So if I go edit 3D, now we have here the model. So if we go back to Grasshopper, this is the model. And if we go back to Sketchfab, we have here exactly the same model. So you can have let's say a farm of GLTF models where you create lots of them and then load them in any viewer that you want. The same happens with any other viewer. You can drop there to any other viewer that you want, and you can use now Grasshopper to be able to create all of these GLTFs files. Okay.
Correct.
Perfect. We can now start addressing some of the questions in the Q&A.
Yeah, exactly. I mean, yeah, just as a word of conclusion. So this is there's more and more features that always come to the viewer. So that's something that we'll keep updating in the future. But one of the things that we might address in a future webinar is that some of you might be aware of like other file formats that we use and that our viewer supports too. So we can also export data in our own data transfer format we call SDTF. That is, even on top of GLTF, is something that allows to retain even more information from Grasshopper models and do more. And this is something that's going to get really big in the next futures that we're going to release soon. And so we're going to soon probably have webinars and also videos, introducing more and talking about these new features and how our viewer, in particular our viewer API, lets you make use of them for even more advanced online applications. So yeah, thank you everyone. So we're almost at the end of the allocated time, but I think we'll stay here for a while with Edwin to take all the questions that we have from you guys. So yeah, let's start looking. I don't know how Should I go through, or Edwin, you're looking at them already?
Yeah, I can tell it to you. So we have. Sorry.
You can start from the top. Yeah, but can we access?
Yeah, I think I'm still sharing my. Oh no, I'm not sharing my. Okay, so yeah, okay, we have one of our users sending a link to like a brand new application that they developed with the API.
Yeah. Okay, but let's have a look at the question. So the first question is, can we access the GH scripts from the demonstration today?
Yeah, of course. I mean, we're gonna put all the links. I think we're gonna share all the links, share all the code examples. So some of the code examples, we wanted a perfect webinar, and we took a couple of shortcuts at the end. So I think it might take a few days to like clean up everything and make sure that all the code examples are really easy to understand. Commented and structured. But code examples would be there. The Grasshopper models. What else do we need? Well, we can even share the link. I think we'll share the links to the full scene with everything in it, so you can play with it and see it with a good frame rate, because in a stream it wasn't perfect. But yeah, we'll have those.
Where will we share the links?
On the front post, I think we'll do that. And I think Ezekiel, you're gonna post the webinar video on YouTube as well, so I think we'll have the links under the video there as well, right?
Yeah. So probably first is gonna be in forum.shapediver.com.
Yeah, exactly. So first in the forum post and then on our YouTube channel.
All right.
So
next
question
one,
about
should I read it, or maybe a bit of topic?
The question.
Will ShapeDiver 1.9 be available for Mac OS as well? If so, when? So Mac OS for the ShapeDiver plugin, I believe.
Yeah, it's pretty. We don't miss much. I mean, we just added. I think Edwin, you could see it when Edwin was sharing his screen. We updated some components. We're trying to basically, we realized at a point that some of the even very old features of the plugin have never been compatible with Mac. So all these import components that have options and they open dialogues that are only Windows compatible. So we try to switch these options to the context menu in Grasshopper, and there's still a couple of issues with that. But we're really close. And then the other hurdle we'll have to go through is to contact McNeil and see what's the best way to basically include this version in the package manager and have like a separate link on Food for Rhino for it. So it's possible that the first release of the Mac plugin might be like the old school way. So we just share, an archive or something, and it needs to be installed manually. But as soon as possible, if we can, we should also have it on the package manager.
Okay, next one says, do you have an example of how you would save the settings that you entered and retrieve later and continue where you left off? So I get they are talking about the states.
So the question would be define settings in this case.
Based on what we show, I think they are talking about the parameters, because we didn't show really what we call in ShapeDiver settings.
I mean, so there's two things, right? So of course, and as we've shown, all the settings, so the viewer settings, like camera positions, the lights in the scene, the environment maps, etc. They're available through the API, so you can update those through the API, and you can even save them, I think, through the API. At least you could in the last version, so I'm pretty sure you can still. Of course, if you want to stop, if this is about those settings, and if you want to stop and go, continue later to update the settings, I mean, then you can use the API to save them, and the next time you're gonna continue, you can load those default settings and update them again. But I think the question makes more sense in terms of the parameters of the model, right? And in this case, we can quickly show, which is actually a good segue into a question about the API, let's say. So we have in the latest version, or Is it the latest or the one before? I don't remember now, because we've released a lot of things recently. But we now have a saved states feature, right? So let's say if I go again to this example, I can play with parameters, and here I can create save states. So let's say here I'm gonna create one. So first state. As the owner of a model, I can make my states private or public, or even organization visibility if I'm part of an organization. So that's the visibility, who can see them. If I make it public, everyone who has access to my model will be able to see this state. If I make it private, it's just for me. But soon we'll be able to share private states. Just like you can share private models, you'll be able to share private states. But this one, I'll make it public, for example, and create it. And these states are then associated with your model, right? So now I have a state. If I change some parameters of this model, like this, I make it so smaller, etc., I can load back these states and see it again. Of course, I can have a lot of states in, so like save a lot of states and load them back and navigate between them. So that's what's already possible. So two things are going to come. I already mentioned that sharing states with someone in particular, so you creating a state, even if you don't own the model, but if you have access to a model, creating a state and then sharing it with someone else, that's a feature that's going to arrive in the next few days. And the other feature that we will have at a point is the ability to save, load, so create, load, update, save states using the API as well. And this is what, so right now, these states cannot be controlled through the API. They can only be controlled through the platform. So I hope that answers more or less.
Up to now, before we had the states, like other users will just save the parameter sets by themselves in their servers and then reload them. Now we are making it easier for them so that we save those parameters and they just have to retrieve an ID with the state, and that's it.
Exactly. Without the states,
if you need it urgently, then you can just do it in the old way, which is you save the parameter settings.
Yeah, as long as your application as a database where you can save all the parameters that are loaded, you can use the API to save those in a JSON object, for example, and then use again the API to load a parameter set that you saved when you load the viewer. Again, you can even load them before you start showing the scene, so it can really look like you started from where you start. But the save states will make that slightly easier to manipulate.
Okay, next question. Do we have to use the API to set conditions that controls a part of the interface display, or there is other way to do it in Grasshopper? For example, if a certain parameter take a value more than X, a part of the interface appears. Okay, so that's basically how to make product logic that will change the parameters, visibility, minimums, maximums.
Yeah, so this is right now, of course, that's something it's good. It's a viewer API webinar, so that's something you would use the API for typically, right? And this logic, because this type of logic is not really part of, like, let's say, vanilla Grasshopper, like the standard Grasshopper. There are scripts and some plugins that are like a bit meta, and can control basically, some logic that if you change something, you can control something else that's in your definition. But that's something that is not compatible with ShapeDiver at the moment, because we really have this basically one parameter state corresponds to one solution, basically, right? So you cannot have this non-deterministic ways to use Grasshopper. That's just part of having a cloud system that works like ours, but in general also is what allows ShapeDiver to be efficient, to have a good caching system where you can, if you use the same set of parameters a second time, we're not going to compute the same solution again. You just take the one that's already stored in a cache to make things more efficient. So in general, if you want to build this type of logic that is not compatible with standard Grasshopper logic, it's good to have this logic on the side of the online application, and to basically then say, okay, like if I make a parameter, if the value is bigger than this, then this other parameter changes value. That's something that you can implement with like 3 lines of the viewer API, on top of the model.
Correct. So Grasshopper is not enough in this case. You need to use the API.
Yeah.
Do I need to use at least Designer Plus to practice ShapeDiver and API?
So like we said, there's some exposition in the console when you upload a model, even as a free user or a designer, that allows to check how the data is structured. Like can I actually get the things that I need to build my online application? But it's true that then if you actually want to take the model out of ShapeDiver and instantiate the viewer and session with the API and start using the API in a separate online application, you'll need at least a Designer Plus, which comes with, I believe, a 1-week trial. Is that true?
2 weeks. 2 weeks.
2 weeks trial for the Designer Plus, which leaves a bit of time to play with it. But yeah, essentially, you can already explore the code examples we have and look at what it looks like when you upload your model and check the outputs, the parameters, everything. But to actually start developing comes with Designer Plus or the accounts above Designer Plus. Yeah.
Correct. So the ShapeDiver plugin you can use, the console in the platform you can use, everything that is in the platform you can use, but the API you need to get the at least Designer Plus. Okay. So the next one says great webinar. So thank you. Does the ShapeDiver viewer include drawing editing functionality? I think they are talking about the spaceform example.
For example, this one. Yeah. So no. So that's also again, like that's kind of like one of the uses of the API, interesting uses of the API to connect this with external UIs, this type of external UIs. I think what we are looking into is to allow some basic ways to interact with the viewer, so inside the 3D scene, but built-in ways, not adding layers with the API. To, for example, pick a point somewhere in the 3D model, or even then if you have pick a point, like draw a line, picking 2 points and drawing a line on there. It's in the long term, it's not impossible that we also have a mode where you can draw a polyline in a plane in the online viewer and this kind of modes. But in the near future, that's the kind of applications that is really suited for API use, I think. Like it's really, I think there's a lot of code. We could share some. There's a lot of code examples and like basic example applications that use like the HTML canvas and show how to like pick points on a canvas and draw them and stuff. And once you have this, it's really like packaging, putting this into a JSON and then sending that to a ShapeDiver model. Basically, you have all the work done. Then all the logic of like recreating a floor plan or creating, like basically building geometry from this data, it's all in Grasshopper. We have like, it's a bit like, the way Edwin showed how to build this like JSON to describe animation data inside Grasshopper. It's much easier to like basically leave it to the Grasshopper side to do this kind of things, right? Like everything that has anything to do with understanding the geometry that you're manipulating and like turning data into geometry and stuff. That's something that's really well done inside Grasshopper. So the idea of a lot of features is to let the developers interact on a very high level with the API, send the data, get the data, and be able to have most of the logic inside Grasshopper.
So in this case, if you want to do the same, you can just look into, there is plenty of frameworks which use the canvas, and you can create these 2D applications, and then basically you have one API communicating with another API, which in this case the ShapeDiver API, and well, that's the beauty of APIs, that they can you can combine different APIs to create great applications. So that will be the solution for now.
Maybe we can also mention that in this case, if there's more demand for a feature like this, we certainly will think about it better. So just let us know if for feature requests, we have like a post on our forum to request features, and we'll always have a look at that and also plan accordingly. So when a lot of people request a feature, we will definitely push that one.
Yeah, the more pressure we get, the more likely it's gonna come. Yeah. So like you know, it's a bit related. Let's say we've had requests for supporting the graph mapper inside Grasshopper. So basically, when you use graph mappers, that they would appear in the controls in the platform, and even be appear in the API. So be able to manipulate in the API. And this is something that we keep in mind. It's not it's not the easiest and the most straightforward thing to support, but that's something that's possible in the future.
Okay, so the next one say, I didn't catch how the animations were triggered from the viewer. I get that they are defined as object attributes from the GH model, but how do you start them from the viewer? Does it require JavaScript coding?
So I can take this one.
Yeah,
I think that's easiest.
yeah.
Okay, in this case, in our example, we basically defined the animation data in Grasshopper, but still on the viewer side, we basically created this animation object to actually be used from the viewer API. So yes, there is some JavaScript coding involved. For our example, we structured the data exactly as we need it for the API, so that it's for us as easy as possible to use. And then basically how you trigger it, it's just a matter of calling a function called start animation for this animation data. And that triggers it. So you can connect it to a button. We connected it to hovering on the object, but you can connect it to anything. You can even repeatedly show this animation loop if you want to. So there are many possibilities on how to do that.
Yeah, and that's what I mentioned a bit earlier. I think, correct me if I'm wrong, Michel, but that's where in our help center, we don't have a detailed code example and everything for this animation part, but that's what's going to come very, very soon after the webinar.
Well,
correct?
Actually, we already have some examples there, but we will expand it definitely.
Yeah, exactly. Okay, I didn't see them earlier, so that's why I was wondering.
There should be an animation section, animations, under migration guides, under interactions.
That's true. So there's already some details about this. Yeah.
Yeah, here basically I only show the very simple ones like translation, rotation, and stuff like this. And here you basically have this animation data item that you can see, and the data.start animation is basically the second to last line, where we then actually start the animation. So this is the triggering of this animation. But maybe
and
read
in our
example,
example,
then you should get it. It's basically just a way of adding this kind of data and adding it to the scene tree.
Okay.
More.
So next question. Thank you for the amazing webinar. It's so great to see that so many awesome features there are so many awesome features being implemented and worked on. My question may be a little bit off topic. What are the plans for the further improvement of the viewer itself? So ray tracing, reflections, shadows, stylized display, etc.
Yeah, so I mean, there's of course that's a broad question. So like we have the idea is that and here, Michel, you can intervene anytime you want, but the idea is that the ShapeDiver viewer is like a way to display, and we want the display to be as good as possible. But as you've seen in this webinar, and we didn't even go through everything. I was mentioning the SDTF and like attributes. We went very quick on it, but the ShapeDiver viewer also contains like a lot of things that are very powerful and are not directly linked to just like materials, rendering, display, lighting, etc. And so we always have to prioritize between those two things, and we try to in the past few months we've added a lot of features related to a bit what we talked in the webinar today, But as soon as you know, depending on what's in the roadmap from this side, from the more like functional side of like interacting with models and getting data from them, etc. When that gets a bit lower, because we're reaching, you know, slowly but surely we're reaching what we want to have in a viewer on that side, then of course focus will go back to, like, let's say, more traditional web viewer features that we can do to implement you know, improvements on this side.
Michelle, maybe just to add.
I'd like to add that, you know, it really depends. You have to, besides mastering the Grasshopper side of things, you have to master the 3D part of things as well. A lot of maps, a lot of lighting. So there's a lot of things you can already do to improve the way your model looks on our viewer as it is right now. So we have a lot of people that know how to use Grasshopper, but they don't know how to actually create the maps needed for that model to shine on the viewer, right? So it's both of a combination of both worlds.
Michelle, maybe do you have a link to? No, but maybe this one is confidential. Okay, yeah, it's a bit of a shame that we don't. Sorry, I almost. There's not so many examples of users who have like basically used all the features that already exist in the viewer. And as we've seen, I mean, you know, like, if you, for example, Sketchfab is an amazing viewer, but if you just upload your model and you don't play for like 2 hours with the rendering settings there, you don't get like a good looking model on there either, right? So that's yeah, there's already like room for improvement with the current state of things, I think, for a lot of models. But of course, yes, we also are considering that.
From my side, we are definitely pushing in that direction, no question.
But
and also one part is
really
also to make it. Sorry.
Ray tracing on a WebGL is not going to arrive.
Yeah, that's definitely. But what I wanted to say is more that one part is also to make it easier for everyone to adjust the models and to work on and improve the models. So we definitely already have stuff in the pipeline to do that, to make it just easier to exchange materials, edit them, and things like this, because this is one of the main parts that other viewers currently do a bit better. Where we are more on the can produce much more data and basically can handle different data sets, how to basically access the material and changing things and really fine-tuning. This is basically something we are also pushing, because we can do a lot of stuff already, but it's maybe currently not as easy as it could be. So this is something in the future where we might provide some tools that will help out with that.
Correct. Also, materials are very important, also, and that's the easiest part. But you need to know how materials work. So as Ezequiel mentioned, well, you need to know that a material is not just an image. No, material involves a normal map, involves a roughness map, involves a metalness map, emissive map. If you don't know what those concepts are, so that's the first thing you need to learn to make your models look good. So that's the base, and then from there, of course, everything else, lighting, everything else. But please learn about materials and texture mapping before trying to go beyond that. Okay. Next one. How can I, as a pro user, make my model public? It says my settings deny this option, but I didn't find it changed the settings to change the settings. How can I, as a pro user, make my model public?
Yeah, I think there's just a small bug that I and it's just a display bug. I noticed a couple of days ago. So for example, here I have this model as private, and if I switch it to public, right now it says that I can't, but really I can. If I save my model now, it's gonna be public, and I think that's the case for everyone. That's not something we restrict. Everyone can have public models. So this like small like UI bug is it's fine. We're gonna solve it. We have a release coming, I believe. I'm not sure this week, but next week at the latest. That has a lot of new things again, including I don't remember what, so I'm not gonna say it because I'm gonna say stupid things. But at least this bug fix will be there. Yeah.
Okay. So you can make it public anyway. So it's just a small UI problem. The second question says, is it possible to display curves in ShapeDiver as lines with thickness and color?
So color, yes. Thickness, that's an age-old WebGL issue, I think. Do you want to say something about it, Michael?
Yeah, it's unfortunate. This is a WebGL issue where WebGL doesn't allow to manipulate the thickness of lines, or at least not on all devices. So our solution was mostly to use meshes for that instead, to basically kind of display the thickness of lines then as a mesh.
Yeah, right. And so yeah, right now using lines with thickness does not work. Like you might have seen it in other viewers, but some viewers have their own implementation that they spend some time on it or things. But yeah, in standard WebGL, it's a bit of an issue, and not just, you know, it's solvable, but like Michel was saying, is that it was when we started playing with that, it worked on some devices and not others, and some browsers and not others and stuff. So it's kind of a bit of a mess at the moment. Yeah. Colors
Correct.
should work though.
Colors, yeah. As a clarification, WebGL is a technology that allows 3D models to be loaded on the web. So it's something high level that we don't control. It's not a problem of ShapeDiver, it's a problem of this technology that allows these 3D models to be there. Okay, next one. Okay, somebody says ray tracing is going to arrive, but will depend on the performance of the viewer's machine. And they
Yeah,
share a
maybe
link.
some input from my side here. That
Okay.
I mean, we are definitely not ruling out to support any of this in the future. It's more of that we also want to support all devices, or basically all devices that are capable of displaying a 3D scene. So that is just one of our main focus. But we are definitely not ruling out anything like that. So it could be a specific mode where you can switch to path tracing or something like this. This is definitely something for the future that we have an eye on.
And we already have some adaptive features, right? So like
Yeah.
some things are disabled on like less performant devices and stuff. So we can also, you know, have selective features depending on the device performance in the future. Yeah.
Okay, next one. On the topic of customizing the 3D scene, as a 3GS expert, how familiar would the SD Viewer API be if I wanted to tweak the 3D visualization, lighting, materials, ray tracing, shaders, etc.?
Michel, you want to take this one?
Yeah, exactly. So basically what we do is we use Three.js as our base 3D library. And we basically wrap a few functions and basically put a bit of a wrapper around it in our API. So a lot of the terminology should be familiar to you. There are some changes. But in most cases, I think if you already have experience with Three.js, it shouldn't be too much of an issue to then also use our API. If there are issues, you can just talk to us in the forum or directly to us about that, how to access things, or if you don't know how to do something there. But you can do a lot of stuff already. It goes a bit deeper into the API, but it's definitely possible.
And as long as I know, you can even use sometimes, like you can create, for example, a 3GS box and you could display that in our viewer, isn't it?
Exactly. So basically, we have an option where you can just put any 3GS object in there completely easily, because that's also something for me. Sometimes I debug like this when I do visual debugging, for example. But you can do any 3GS, you can just put it into the scene. And it's even possible to not even have a Grasshopper scene open, just a viewer with some 3GS data if you want to do that. So all of that is possible, yeah.
Yeah, so
Okay.
as a quick word on this, it's always a bit the same, is that we try to be flexible and make it still possible to do what you can do with like another viewer. Like let's say if you were to develop your own completely custom online application, 3D online application using just Three.js or whatever, custom configurator. The idea is that there's no reason not to use ShapeDiver at any point, because you can also do like a lot of these custom things in the ShapeDiver viewer. But and the fact that you have, you know, this Grasshopper connection in the back, So these parametric models in the back can just add to it, right? And like simplify things and so, but it's not like you're giving up on anything by using the ShapeDiver viewer and using the ShapeDiver approach to parametric models. The idea is to have the best of both worlds, essentially. Yeah.
Right. Next one, correct me if I'm wrong. I think the custom preview line weights human plugin can be used for displaying curves with custom thickness. So that I can answer, I think. I mean, I was just checking that component, and of course you can see the thickness of the line in the Rhino viewer. But remember that we are not using the Rhino viewer. We are using the ShapeDiver viewer, which is a WebGL viewer. So it's not the same. We are not using the Rhino viewer as at all. is Grasshopper headless in this case. So even though this component in Grasshopper allows to have this thickness in the curves, you cannot expect the same behavior when we are using an online view.
So, and of course that's not ideal, right, in terms of user experience. So that's something that is really complex, but we have in mind as a direction to work on, is to either be able to have like a very fast preview when you work in Grasshopper of how things will look online. So live as you work on it, and we have some ideas on for this direction. On the other hand, something else that can be explored, we've always tried to like make the preview inside the Rhino viewport, look close to what you would get at the end in the ShapeDiver viewer. But of course, a lot of the visual features, some things are missing in Rhino that we have in the viewer, and vice versa. So if you anything you preview in a Rhino viewport, unfortunately at the time is not going to be one-to-one compatible with what you'll get in the online viewer. But yeah, we know about this in terms of user experience and thinking of how to make this user experience better.
All right. And in the human plugin, we mainly in the human plugin we support the texture mapping components is what we use mainly in the human plugin. The other ones we don't. However, now that I see how the thickening of the line looks like in Rhino, it seems that in the human plugin this is being converted somehow into a mesh or something to show this thickening. Maybe I'm wrong, but it's what it looks like.
Maybe.
So we could look into maybe in the future support this. Maybe
well, we have
depending on what is created internally.
We could add our mesh pipe components to the plugin as well. Just use that for lines.
Okay, next one. Did you already experiment with KTX texture compression?
Is that one of our extensions, Michael?
Currently, we don't have it implemented, this extension. But it is basically an extension that we can implement for GLTF. I mean, we just have to see if there's a use case for that, because to use this extension, we also have to compress the textures on the Grasshopper side to actually make use of that. But sure, I mean, these kind of performance improvements is always an option for us. So this is continuous development for us, yeah.
Everything we can compress, we try to compress. So we've had, actually, I'm not sure if we did a change recently, but we have a lot of tasks related to this, compressing a maximum number of things. And I think something that is already released or will be released very soon is also using CDN, so content delivery networks, for everything that comes. So we already use it for some of the assets, but using for like most things that come to the viewer. So that's like the small performance improvements. We always keep an eye on them. Yeah.
It is coming, so it's not out yet, but you should
It's not out
all
yet.
feel a performance improvement about this. So yeah, looking forward to that.
Yeah.
Okay. I think last one. You mentioned that the ShapeDiver plugin 1.9 for Rhino 7 Mac OS might be available as an archive before it's available via the package manager. Can you already give an estimate on when this may happen?
Yeah, the question here is how lean we want to be. There can be a version rather fast, but it's going to miss some of the features of the plugin, right? So like being able to use all the import components and text input and sets like which formats you want to allow as imports, the size of the files and stuff. This is still a UI issue on Mac, but I think so. Either it's still a decision that we have to take, whether we wait for this to fix this and make this work and have like a more well-rounded version for Mac directly, or if we get like lean and get something fast, which could happen then in the next couple of weeks. But yeah, we'll have a discussion internally and try to get this as fast as possible. Maybe we should have had a poll about how many users use a Mac for Grasshopper, because we're always under the impression that it's a very, very small, very small part of the users are on Mac, but I mean, we value all our users, so of course it's important to support it there.
Okay, so, and the same person said, I prefer fast than complete.
Okay.
I mean, maybe he can reach us and see maybe if he has a project or something that we can help him with, then we could look into prioritizing such a development.
For sure.
So you could contact us to have a look at what you need. And that's all. I just wanted to give a thanks to Forma that they share their link of the configurator that they are developing. So it's looking great. And
thanks also to all the users who let us show their examples during the webinar. We've showed a few of the best use cases that people have done with the API so far. So yeah, we'll have on the forum links, explanations, Grasshopper models. We'll have the documentation. We've been expanding it very fast recently, so it's like more advanced examples, more code examples there as well. And I think even we'll have Michel will work on a series of videos aimed at developers with more code examples, curated explanations and stuff. So be more and more tools.
So there will be a YouTube series where I basically will guide developers through the process from the complete beginning to really complex stuff, so that everyone has an idea. And this is more than being a bit slow paced and really tutorial series, but I think this will help out a lot of people.
Yeah, and we'll for sure have more webinars. I think there's still a lot of advanced topics we did not talk about, so stay tuned. And yeah, looking forward to seeing you again next time. And yeah, always talk to us on the forum. And if you have requests, reports, things you need, let us know. All right, I think that's it. Thanks to everyone. That was a fun one. Yeah.
Thank you, everyone. Remember to subscribe to our YouTube channel, leave all your questions in our forum, and any contact requests via our website as well. So have a great day. Have a great Tuesday.
Bye, everyone.
Thank you, everyone. Bye-bye.